Welcome to GED Mastery. This is a practice test for the No Calculator section. There's only one rule for this test, no calculator. On the real test, the first section is the No Calculator section. It has about 5 questions, and this practice test will help you prepare for that section. Number 1, evaluate the square root of 80. So hopefully before you've taken the test, you know some of your squares, like 2 squared is 4, 3 squared is 9, and so on. So the square root of 4 would be 2, the square root of 9 would be 3, and I'd recommend learning these all the way up to 12 squared, which is 144. If you recognize these numbers, it will just be easier. But there's no perfect square root of 80, so we've just got to break it down into factors of 80. So I know that 80 is 8 times 10. So I'll go ahead and break that down. And I could do 2 times 4 is 8. And 2 times 5 is 10. I could break this further down into 2 times 2. So here's the prime factorization of 80. We want to look at all the numbers on the end here. So we've got 2 times 2 times 2 times 2 times 5 equals 80. Now if we multiply 2 times 2 times 2 times 2 together, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I do know that 4 squared is 16. So in other words, the square root of 80 is the same as 16 times 5. Now I can take the square root of 16. It's 4, right? And if I take the square root of the 16, I've got to put the square root outside of the radical. So the square root of 16 is 4. That goes outside. And then the 5, I can't take the square root of it, so it just stays inside. So my answer is 4 radical 5. Number 2, evaluate. And it looks like I've got an order of operations problem, PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction. And remember that these go together. So let's do what's inside the parentheses first. And I'm going to write everything else down. So 5 minus 7 is negative 2. Okay, and there's nothing else to do inside of the parentheses right now. So let's go on to multiplication and division, and I'm just going to go from left to right, multiplying and dividing. So my first one is negative 3 times negative 2. So I'll carry down this 2 here, and negative 3 times negative 2 is positive 6. And then I'll write this down, divided by negative 2. Now I'll go ahead and divide that. 6 divided by negative 2 is negative 3. And I'll carry down this 2. So now I've got 2 minus 3 as my last step, and that is negative 1. Number 3, solve. And I've got to add some fractions. Remember that when you're adding fractions, you have to have the same denominator to be able to add them. I have different denominators here, so I'm going to try to change this one to a 6. And what do I need to multiply the 3 by to make it a 6? I need to multiply it by 2. But if I multiply the bottom by 2, I have to multiply the top by 2 as well, because 2 divided by 2 is 1, and I could multiply anything by 1 and it's still the same number, right? So let's go ahead and do that. 2 times 2 is 4, and 2 times 3 is 6. So 2/3 is the same as 4/6. We just made a common denominator. And now we can go ahead and add across the top and keep the bottom the same. So 4 plus 5 is 9. And we'll keep the denominator there. And now we have to reduce this fraction. So 6 goes into 9 one time, and then there would be 3 left over from that 9. And now we could reduce this. 3/6, we could divide the top and the bottom by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So our answer is 1.5, C. Number 4. Put the following numbers in order from least to greatest, and we have a mix of decimals and fractions. So to make it easier, let's convert all of the fractions to decimals first. And since we can't use our calculator, we'll just do it by hand. So I'm going to just do 1/8 and then add a negative sign afterward. So 1/8 is like 1 divided by 8. How many times does 8 go into 1? 0 times. Let's add a decimal and a 0. 8 goes into 10 once. So we'll go ahead and subtract 8. And we get 2, add a 0. 8 goes into 20 twice. 8 times 2 is 16. We'll go ahead and subtract. And 8 goes into 45 times perfectly. So that's our answer. So negative 1/8 is the same as negative 0.125. And let's go ahead and do the same thing with 2/15. So 2 divided by 15. Fifteen goes into 2 0 times. We'll go ahead and add a decimal point. 15 goes into 20 once. Let's subtract. 15 goes into 50 3 times. 15 times 3 is 45. Let's subtract, and we get another 5. So that means that that 3 is probably going to be repeating forever, and that's what that little line means, that that 3 will continue repeating. So negative 2/15 is the same as negative 0.13 repeating. And we have one more fraction. Let's do it. 1/7. So 1 divided by 7. 7 goes into 1 0 times. We'll add our decimal. 7 goes into 10 once. Let's subtract. 7 goes into 34 times. 7 goes into 20 twice. 14. We're left with 60. 7 goes into 60, let's see, I guess 8 times. And we could probably stop there because we already see that that's different from this one. So negative 1/7 is the same as, let's just round it to negative 0.143. Okay, now we have to put the numbers in order from least to greatest. Now let's remember, since we're in the negatives here, it's going to be different from positive numbers, because positive numbers, the digits, let's just say we're doing some even numbers here, will ascend, while the negative numbers will have the biggest digit as the smallest number. So let's look for the biggest value here, because that will be the smallest negative number. And that would be negative 0.2. Negative 0.2 is kind of like saying negative 0.20 or negative 0.200. So we're going to always look at the tens digit first. And the tens digit, all of them have 1 in the tens digit except for this number. So this has the biggest digit in the tens place, and that's what makes it the smallest negative number. And look, B is the only one with negative 0.2 there, so we could probably just pick B and move on. But let's just verify that we did all our work right. So the next one should be negative 1/7, then negative 0.14, right? And then negative 2/15, and then finally negative 1/8 is going to be the biggest number out of all of these because it's the closest to 0. Number 5, the numbers -5 and 7 are plotted on a number line. What is the distance in units between the 2 points? So let's just sketch this out here, and let's use odd numbers this time. So we've got 1, 3, 5, and 7. And let's go into the negatives, -1, -3, -5. Okay, and I'll just put in a tick mark for the others. 2, 4, 6. All right, so if I wanted to get from -5 all the way to 7, how many tick marks would I go? I could just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 units between them. Or I could also take the absolute value of these numbers. So -5 minus 7, we're going to use distance with a minus. And -5 minus 7 is -12. But remember, we've got the absolute value sign, which means that anything that comes out of that is positive. So the distance is positive 12 because distance cannot be negative. So our answer is D. Number 6, what value of x makes the below expression undefined? Okay, if we're looking at a fraction and we want to find what's undefined, it's whatever makes the denominator 0. So we're looking at the bottom of our fraction here, and we want to know what makes that equal to 0. So instead of factoring out this quadratic, let's just substitute each of the answer choices in here and see which one makes the expression equal to 0. So let's start with 1. 1 squared minus 4 times 1 plus 3. So 1 squared is 1 minus 4 plus 3. And 1 minus 4 is -3. And -3 plus 3 is in fact 0. So it's the first choice. Let's just substitute another one in there and see that it's not 0. Let's look at B. So we've got, if we put in -3 squared minus 4 times -3 plus 3. -3 times -3 is +9. -4 times -3 is +12 plus 3. So 9 plus 12 is 21. And 21 plus 3 is not 0. And we're looking for a 0 in the denominator here. So we do want answer choice A. Number 7, multiply. And we have two numbers with decimals. So I'm going to put the longer number on the top and the shorter number on the bottom because it will be easier. And it kind of doesn't matter if you put the decimals in at this point. Honestly, I think it makes it more confusing. We could just deal with that later. So let's go ahead and multiply. 2 times 3 is 6, plus 1 is 7, and then 1 times 3 is 3. Add a 0 because we're coming down 1. So 5 times 4 is 20. Let's write that over there. 2 times 4 is 8, plus 2 is 10. And 4 times 1 is 4, plus 1 is 5. Okay, so I've got 5, 3, 7, 5. Now what do I do with my decimals? I'm going to count the number of digits that come after decimals. 1, 2, 3. And that's how many places I need to move over from the right. So 1, 2, 3. My answer is 5.375. So that would be C. Evaluate. the square root of 45 minus 2 radical 5. I'm going to just look at the first term and break that down. So I know that 45 is 9 times 5. And look how convenient. I already see a perfect square here. So I can take the square root of 9 and put it outside the radical. The square root of 9 is 3. And then the 5 stays inside because I can't take the square root of it. So I'm going to put that back in here. So I've got 3 radical 5 minus 2 radical 5. And I can kind of treat this just like a variable. Since they both have the same one, that means I could just do 3 minus 2, and I'm left with 1 radical 5. Or we could just say radical 5. And so that would be B. Evaluate when x is 2 and m is 4. Okay, let's go ahead and substitute in these values. So 9 to the x is 2, so that would be 9 squared, over 3 to the m is 4, so that would be 3 to the 4th. I'm just going to multiply this out and see what happens. 9 times 9 is 81. And then 3 to the 4th means 3 times 3 times 3 times 3. So 3 times 3 is 9. 3 times 3 is 9, and 9 times 9 is 81. And 81 divided by 81 is just 1. Now another way I could have done this, before I even started, I could have noticed that these had different bases. And I know that 9 is 3 squared, so I could just change the top to have the base of 3 and then have that squared there, which would be multiplied by that x. And that would be over 3 to the m. Now when I substitute those values in, x is 2, so that would be 3 to the 2 times 2 over 3 to the 4th. And that's the same as 2 times 2 is 4, so that would be 3 to the 4th over 3 to the 4th, which is obviously also 1. Okay, so this is a little bit different from the fraction because I'm not looking for what makes this 0, but what makes a square root undefined is if the number inside of it is negative. Like let's say it was -4. I can't take the square root of a negative because there's no number multiplied by itself that would make a negative number. So I want to see which of these values makes a negative number in here. So let's try the first one. 6 squared minus 2 times 6 minus 6. 6 squared is 36 minus 12 minus 6. Oops, I don't need that. And then 36 minus 12 is 24 minus 6, and that would still be a positive number, so that would not be undefined. Let's try -2. So -2 squared minus 2 times -2 minus 6. -2 squared is +4, and then -2 times -2 is +4. And 8 minus 6 is 2, so that's also a positive value that we get. All right, let's try C. So 1 squared minus 2 times 1 minus 6. So we've got 1 squared is 1, 2 times 1 is 2, so -2 and minus 6. 1 minus 2 is -1, minus 6 is -7, so that does give us a negative value. And let's just check the last one to be sure. So if we put in -3 squared minus 2 times -3 minus 6, -3 squared is +9, Negative 2 times negative 3 is positive 6. And those would just cancel out and give us positive 9. So yes, C is our answer because it gives us a negative value and we cannot take the square root of a negative. Let me know what you think in the comments. You've got this.